Should we talk to Chardsy? World's about to get
Well, I got
charred and freaking air fried. Should we air fry this guy?
Go ahead, CB.
Yes.
All right. Chardsy, you are up. Welcome to the call. Let's get a hater on the line. Go ahead, Chardsy.
Hater of what?
Yes. Welcome to the call, sir. You've talked to Flat Earthers a bunch, right?
Can I talk now? Are you gonna let me talk?
I mean, the fact that you've been unmuted is a good sign, and you're being called on. I mean,
Oh.
anyway,
do
you've
I-
talked to
do
Flat
I
Earthers
get-
a lot, right?
Free speech in your free speech channel now?
Nah, but so have you talked to Flat Earthers a lot or no?
Yeah, a fair amount.
You feel like you understand what they're saying at this point, or are you still like not sure about their position?
Yeah, I wouldn't say I really understand it.
Oh, okay. Well, what do you
can
understand so
about
far?
it?
Yeah.
Well, I understand that you think the Earth is flat.
I mean,
Well, why do we think
I mean that's fairly obvious. As to
do you
why,
know what that means, though? Do you know what that means?
why don't you tell me what that means?
I feel like you've been around for a while. You don't know?
Well, that's why I'm asking.
Damn. All right. So you must not have been paying attention.
You just go away and reset.
Yeah. Did he not? He just reset, huh? Damn.
Well, I'm just asking you for clarification about what you believe. If you don't want to
Why?
discuss
Why
with
do
me,
you
that's
think-
fine.
What do you already know,
Well, I know you believe the Earth is flat.
bro? What does that mean?
Do you need further clarification about what
Yes.
that means?
Yes.
What are you confused about?
No. We're asking you if you know what flat Earth is or what that means. Because I think a lot of people don't know what that means. Because if I were to line up 10 random people off the street and I told them to describe flat Earth to me, they'd probably talk about a solar system with a flat planet in it.
Right, and I've told you I have a rudimentary understanding, but I don't
All right,
fully
tell us.
understand.
Tell us what is the current understanding you have.
So, my understanding is you believe the Earth is flat.
Bro.
Right,
Clearly,
okay.
the fact that we're flat Earthers, that's given. So what does
Okay,
that mean?
so don't be so hostile. Calm down.
But like you're saying, like I flat Earthers understand they exist. They say the Earth is flat, but that's not saying anything. That's like if your math teacher comes to you and says solve for X, and you put X equals X. Like,
You're
bro,
getting really worked up about it. That's okay.
I'm not worked
Calm
up.
down just a little bit.
Bro, this is just how I talk.
Do you want
so
me to talk, or do you want us to keep talking?
you're going in circles. So what does flat Earth mean?
Well, besides what I've already said, right? My understanding is that you believe that there isn't a solar system as it's generally conceived. You believe that the planets and the sun and the moon rotate around the Earth. Earth is some sort of flat plane that extends some sort of distance that nobody seems to know the exact amount. It could be infinite, it could not be. Nobody here seems to know the actual answer to that question.
So what the fuck is happening right now?
Right. Well, I'm just saying from what I've asked.
What do you mean by planets, though?
Planets, the different bodies, the celestial bodies in the sky that are not stars or comets or asteroids.
I know the name is Wandering Star.
That's an old name. I guess
that's what planet means. Yeah.
Okay. But the difference between planets or wandering stars and stars is that stars follow pretty predictable, even patterns, whereas the wandering planets follow much less even patterns throughout the night sky, right?
Yeah, but do you think that we think that they're things that you can land on?
It depends on who you ask. Right? Because here's my perception from what I've seen from interacting with people who believe the Earth is flat is that they have very differing opinions on the planets. And that you can't ask one person for their opinion and apply that to everybody else.
So
Because-
what else have you heard flat earthers say about planets?
I've heard people say that the moon is a hologram.
Bro, what the?
The moon's not a planet.
I'm not trying to say, yeah, okay, it's not. That's fair. But that the planets are holograms. That,
You
Bro,
said
and I'm not trying to say that this is what you believe. This is just what I've heard. And that's why I think it's a very difficult thing to understand, because people believe a lot of different things, and that's why I'm asking you questions,
Do you
because
think
I want to
that
understand better.
you're not even talking about the Earth at all. Has he mentioned the
No.
Earth even once, bro? Like, what?
Not once.
Do you want me to
You're
talk
like,
about
oh,
yours?
the stars, the solar system, the planets. What does that have to do with the Earth?
Okay, so the Earth is flat, obviously, but there seems to be some contention as to the size of the Earth, if the Earth is infinite or
No,
if
there's
the
no
Earth
there's
is
no
finite.
contention. There's no contention. It's no one knows.
No
Wait,
one knows.
can I? So,
Well, no
what?
one knows. Why are you
Let's not.
laughing about that though?
You're,
Because I've heard people say different things. I've heard people say that the Earth is infinite. I've heard people say that the Earth
okay.
is finite, but
Is
it's
there
bigger
any
than
such?
Oh,
because
cool. Hey,
You know
kangaroo guy.
anything that's infinite?
infinite, as in it goes
Sorry,
on forever.
go ahead, CP.
No, I just wanna hold up because he's like, well, this is an issue. Okay, is the universe infinite or finite?
I believe the infinite, in the infinite universe.
Okay. Is it a like so? Okay. All right, go back to you, kangaroo guy. Back to you. I don't even know
That's
what
all
to go with
right.
that. I don't know what to do
Why
with
would
that,
you?
honestly.
Where
Right.
would you get the information that the universe is infinite, though?
Okay, so are we asking me about my beliefs now, or do you want me to continue going
Yeah,
on
I'm just
about?
interested because you just said something, and then we'll just go back to the Earth. But where would you get the information that the universe is infinite?
Because as far as we can observe, the universe is expanding in all directions from everywhere at the same time.
How is it
So
So
there
that
would
infinite?
would be
be no
not
edge to it.
infinite because it's expanding, right?
Like what?
Well, infinite spaces can expand.
Huh?
Into
Yes.
what?
Into infinity.
Oh,
What the hell?
making stuff up.
What have you haven't taken number theory?
What's that?
No, that's got nothing to do with the universe, dude.
No, it has to do with the concept of infinite spaces of expansion and contraction.
Right. Present something that's infinite.
The universe.
Bro.
And how do you know that?
Because
Well,
it's been observed to be infinite.
no, it
How can you
hasn't. Because
observe something to be infinite?
Because
right.
it doesn't end. There's no end to it.
Just keep
Or
on
how can you
counting, buddy.
observe something to be infinite that has no end? What's the observation?
The observation is that there is no end.
How
How
would
is
you
that an
observe it if you have
observation?
an end?
Constantly, forever. So if it expands constantly forever and there's no end
And
to
how
it,
do you
then it
observe
is
that?
infinite.
And how do you observe that?
By looking for an end. I
And how do you do that?
Oh, you can use lots of different tools. I think the telescope is the most commonly used one.
So you just look through a telescope and you say, this is forever expanding.
Well, you look at the distance between objects. You can see that the distance between the objects is expanding.
How do you get the distance between the objects?
Well, have you taken trigonometry?
No. How do you get the distance between the objects in the
Right.
sky?
So in trigonometry, right?
You can't do trigonometry on the stars.
No, hold on, let me speak. If you have a known fixed point, such as our planet, and you can observe the distance between one point, and you can observe the distance between another point, and you know
How do you
the
do that?
angle between those two, then using trigonometry, you can determine the distance between the 2 points.
All right. So I'm on Earth. I'm gonna point at one star, and then I'm gonna point at another star. And how do I know the distance between those two stars?
Because you know the distance between your point of observation and each individual point.
No, you don't.
Using
How?
the angle.
No, that's the issue. No. All
You
you
use
have is the angle
spectroscopy.
between. The issue is you don't have the angle between the two. You need one of the sides to be able to solve for the distance between the two.
Yeah, you've got no value
Right.
to work
You
on.
have two sides because you know the distance between
No, you don't.
each star and
No, you
yourself.
No,
No, you don't. You don't know if one of the stars that you're looking at is closer to you than the other one, but happens to be dimmer, right? So it looks to you like they're the same distance because
Well, you can
you might.
determine that actually.
No,
But
you
that's
can't.
the whole
How?
point. So you're saying,
You
oh,
can.
well, you can use trig, and then we know how far they are from us or
Yeah.
far from each other, but you don't actually know that.
Well, you use trig to determine how far apart they are from each other.
No,
Using
you can't do that though. You
Can't do
can't
that because you don't know the
literally how
distance.
no.
You only know an
that's how
angle.
trigonometry works.
This is
You don't
the
know how the
issue.
distance.
And you can
You
literally
have to-
measure the angle because
No,
we're
you
making
can measure
the observation.
Chardsy.
You can measure the
Chardsy,
angle, but
all
you
you
don't have
can
any
do-
distances.
Exactly, Chardsy. All you can do is measure the angle, but you have to assume that they're equidistant to you.
No,
Or
you
from
don't
you.
have to assume they're equidistant.
Well, that's the whole point. If you don't assume that, right, then what?
Then
How do you? How far are they then? You look at a blip in the sky, a blinking little flickering thing in the sky. How do you know how far it is?
we can use a spectroscopic analysis to determine the size of them.
There you
No,
go.
And
you
then
can't.
using the size and the radiance
No,
of
you
them.
can't because you need to.
This
In
is
order
an
to get size, you need the distance.
this is an
Need
old
size for spectroscopy.
this is an
No,
old
can't.
argument. This is an old argument, bro, and you can like relate it to like if you're to take 1,000 flashlights in the middle of the salt flats and everybody goes a distance, whether it's the same or like differentials, like like some are closer, some are further, but you don't know like one flashlight might have like a suit like a certain illuminance to another one. So like what if like one that's closer to you has a dim bulb, but one that's farther than you has a brighter bulb, and you, in your logic, would think the opposite. Because it's brighter, it's closer, but in actuality, you don't know the illuminances of the objects in the sky. Like, and they could all be at the same distance, but they all just have a different illuminance. And this is where you have to just believe what they tell you is when you're saying, oh, we have instruments and we can do spectroscopy and we can just do that. Dude, that's all bullshit, bro. Because in reality, it can be debunked in that logic. So you just got to stop with that nonsense, bro.
And worse,
Yeah,
and
'cause you
worse
need-
yet. Oh,
Okay, so how
Right.
about you
ahead.
tell me
Right.
how it works then? Because obviously I don't know very much.
What do you mean
Could
how
you
what
ex-
works?
Could you explain to me how it works?
How what works?
How the universe works?
What, you don't
Bro.
know how the universe works. What
That's
are you talking
literally
about?
a meme. That's literally a meme that we have. What?
Yeah.
Chardsy, that's the whole
So
point.
so how
This
far
is-
away
this is
are
all-
the stars?
Chardsy.
I'm saying they're different
Oh
distances.
no, we don't. That's
Undetermined.
Because
That's
if
the whole-
it's if the answer is we don't know, that's not very convincing to me.
We're not trying to
See,
convince
that's
you.
your problem.
I'm not
Chardsy,
trying-
that's your problem. That's your
Go ahead.
problem, dude. You want to assume that all the shit is already known, and
I
for
don't
whatever
think it's
reason,
already known. I don't think
well,
everything
it sounds like you do,
known.
man. You're saying,
I
"Oh,
think
we
certain
can
things
calculate."
are already known.
Not what
But that's
stars are.
different.
To know to more questions. I don't think that everything's already all figured out.
But here's
But we do know
here's the
certain
kicker.
things.
Here's the kicker. Here's the kicker. These things that you are asserting that are already known are then themselves actually the big questions. That's one of the points here. You're saying we know the distance from a star. We can calculate this or the other thing. How
We
do you know
can.
that? Oh, we're just kind of guessing. Oh, well, that's the whole point. We're wondering. Oh, well, maybe we can't actually figure this out, given these kind of properties of things that we're talking about. Oh, well, we can't actually determine that with these tools. Oh, maybe we'll figure it out one day. But as of yet, oh, well, it doesn't seem like we do. But you guys
Using known
assert
physical
your
properties,
worldview
we can
asserts-
come up with pretty
your
good
worldview,
estimates.
your worldview
No, you
asserts
can't.
that we do know these things or that we can, given certain assumptions. But that's the kicker. You have to assume shit. That's what we're
Right, you
we're
have
kind
to
of
make
pointing out
certain
to.
assumptions.
No, you don't.
Yeah, like
you want
the
to,
first assumption,
have
right?
to.
The first rung on the cosmic ladder is
Ooh.
I don't know what that's in reference to.
Exactly.
Well, that's the first measurement that needs to be known before you can measure any of these stellar objects, right? So the first rung on the cosmic ladder is what?
I've never heard of that expression before. I don't know what
Exactly.
you're talking about.
So how'd you get your distances to the stars then?
Well, you look
It's
at.
okay. You have to assume things.
Do you want to let me talk, or do you want to just talk over me?
Well, we're gonna have to teach you what the cosmic ladder is, bro.
Yeah,
First.
and that's literally what I'm here asking, and you guys are asking me to come up with stuff
Okay,
and
it's the
defend
size
it. I'm
of
asking
Earth.
you guys to
First
teach
rung on
me,
the
and you don't want to
cosmic
do
ladder
that.
is
You want to argue with me instead.
okay.
No, we're gonna
First
teach you.
rung on the cosmic ladder is based on the Earth's radius.
Okay, what is the Earth's radius?
3,959 miles.
Okay,
Right? That's what they say it is.
okay.
Now, do you believe that?
I don't know off the top of my head.
God damn.
Yeah, I'll take your word for it if you're saying
Okay.
that's what they're
Right.
saying
Well, this
it
is what they say. So, do you agree with them?
I'll agree with you saying that that's what they say.
Okay. Now, how did
Because
they get that?
I assume they use trigonometry. I mean, it's been known for the radius of the Earth has been known for quite a long time.
You didn't even know what it was.
No. Do I need to know the
How
exact?
do you know it was known? What the fuck is going on right now?
Now, the next one is the distance to the sun. So, do you know how
Okay.
they got the distance to the sun?
How did they get the distance to the sun?
They assumed that Venus was the same size as the Earth. Earth's size is still undetermined because we can go back to that. Venus, same size as Earth, transited across the sun. Right? Time to transit.
Okay.
Got the size and the distance.
So
So how did they know that Venus is the same size as the Earth that hasn't been measured yet?
Venus and the Earth aren't the same size.
That was the assumption.
Then you
That's
just cooked the whole
distance to
ladder, bro.
sun.
Wow.
You
The
just
whole
cooked your
ladder.
whole stuff.
Who
Yeah.
came up with this ladder thing?
Not flat earthers.
Astronomers.
Which
Kepler
astronomer?
and Huygens. Kepler and Huygens. I think you should go and look them up before you
Okay,
get stuck any further.
I'll look it up. What's it called?
He said they're not the
Cosmic
same.
ladder.
You know, the irony is that trigonometry uses straight lines, not curved lines, by the way. That's kind of the irony right now. So for you to invoke using a radius to trigonometry, it's kind of fucking like, wow, bro. Like, are you really going to go there? Because then that means you don't even know what trigonometry is. I'm just saying.
Well, I mean, you got a point
Wouldn't
there. But Chardsy, if you're going to use trig, you have to be using trig from the center point of a sphere or of a circle.
You'd be in the
That's the
center
only
of the
point.
Earth.
No, you don't have to be at the center point. You just have to know the difference between the center point and your point of observation.
Then you don't know
That's
that.
what we're talking about. That's what I'm talking about, calculating from there. But in order to actually get there, you only have the surface to work with. So if you're going to work with the surface,
So if you have multiple points of observation, you can infer the center point.
So if we had
Let's explain.
Yeah,
Let's
go
explain to
ahead.
this young man. Yeah, let's just explain to this young man because he's getting there. Let's just
Yeah.
explain to him how the radius come about in the first place.
Yeah, that's the first step. Yeah.
Sure, I would appreciate that.
Do you know? You don't know?
How the radius came about
Yeah.
of the Earth?
Yeah.
Noah Venus.
Does it have to do with Venus?
No,
Actually,
no.
kind of.
Have you, surely you've heard of Eratosthenes, right?
Yeah.
Yeah. So sticks and shadows, measured the sticks and shadows, the angle between them at a certain distance.
Right, at different latitudes.
Yeah, and then created an equation with 360 degrees in it to create a ball, like an arc of a ball.
Mm-hmm.
Yeah.
Yes, I've heard of that. I
Yeah,
believe
so
Have you
we-
heard of Polaris?
the star Polaris.
Yes. Have you heard of that? North Star, Polaris?
Yeah. 4 degrees off of the North Pole. Can't be seen from the southern hemisphere.
It's directly over the North Pole.
No,
So-
not quite. It's about 4 degrees off. It's not directly above it, but it's very close.
0.0
That was used in navigation.
0.027. Yeah, 0.027 degrees. That's its supposed rotation, annular. So it's technically the North Star. So
That's what it's
our
called.
latitudes that we use are angle measurements from the Earth that we stand on to the ground position of Polaris. So that's an angle measurement. So as we get further away from Polaris, 1 degree every 69 miles, that's how we developed our latitude. So that's where the radius come from. So when we got to the vanishing point, 39.59 miles, that's how we worked out where the equator was. So now that you know that, do you know what an angle is?
50 miles from Polaris. Ground position of
1 degree every 60 nautical miles or 69 statute miles. That's
okay.
1 degree. Yeah, that's how we come up with our latitude system.
Right.
So the vanishing point of Polaris would be the equator. That's your 39.59.
Roughly.
So
you can still see Polaris from some points below the equator because Polaris isn't directly above the North Pole.
Well, so they say, but no one's proved that. But what I'm trying to explain to you is how they come to the radius. Yeah?
Okay.
The radius was come about by angle measurements to Polaris. Now, do you know what an angle is?
I've never heard of the concept myself, but maybe you could explain it to me.
What, an angle? You've never heard of an angle?
No. No, I'm shitting you guys.
Why are you being ridiculous now?
Because you're being rude to me, and I don't appreciate it.
Oh.
I'm gonna fuck with you a little bit.
Who's being rude?
We're trying to help you, dude.
Yeah, and I appreciate that.
Chardsy,
I didn't think anyone was being rude, man.
You might
So an
understand.
angle.
Can we continue with this line of thought?
Yeah, it's a technical question.
An angle is two
Minutia,
straight
you might
lines that meet
not
at a
know.
vertex.
Okay, yes.
An angle is two straight lines meeting at a vertex. Now, when we're measuring Polaris, where do you think the vertex is?
I don't know, man. Where's the vertex?
So the line from Polaris straight to the North Pole, and then the line from my feet looking at Polaris to the ground position of Polaris, that's your vertex. That's two straight lines. That's 39.59 miles of completely straight.
Okay. I thought it was traditionally from you to Polaris to the horizon. And the distance between Polaris and the horizon was how you measured your latitude.
When you when using celestial navigation, you level your measuring device with the horizon because the horizon is flat.
Uh-huh. Right. It's a solid point of reference.
No, in the globe model, though, you presume that adjacent line is a tangent to a ball. Otherwise, it's basically the ground. Right? That's the dichotomy trying to be worked out here. Now, if you guys assume that if you guys assert that you're on a ball, but these mechanisms, we just use them like that. What you have to present something that actually demonstrates that indeed it is just a tangent line. But so far, it's not exactly determinable.
Okay. So if the Earth is flat and we're measuring the angle between Polaris and the North Pole, how far above the North Pole is Polaris?
You don't need that.
No, you do. Well, I mean, you could calculate it, right? If you know that X amount of miles every latitude causes a 1 degree shift in Polaris, then how far above the Earth is Polaris?
That's an estimate as well. At what degree per 69 miles? Because it's also based on the radius.
So you guys were bashing me earlier for saying estimates, but now you're saying estimates, and that's acceptable.
It's not our estimate. It's not our estimate.
Well, it wasn't my estimate either.
It's a globe estimate.
There's also an implicit assumption in that if you're one has to assume that what you're looking at is in the space that, like, there's the apparent location of a thing, and then there's the actual location.
Right.
So you have to assume that as you're traversing on the ground, what you're looking at, basically your line of sight, your apparent line of sight to it, intersects with any other apparent line of sight from everybody else at the
Okay.
exact where the thing is. Now that's actually not determinable either, because one would have
Oh.
to go there basically and actually, look back and
Right.
confirm that, which is not.
So what I'm hearing is there's a lot of assumptions here that go into
Yeah,
this.
with the
Well,
globe.
here's the issue.
Yeah.
No,
Globe's the
the
assumption, right? So
Yeah,
don't put that back on us. We're telling you what you're
I
supposed to
thought
believe
you
in.
were telling me how the flat Earth works, man.
No, we're telling you how your globe works, dude.
Oh.
Yeah,
Well, I
Chardsy,
already
what I
know
was-
how the globe works.
Chardsy.
I
No,
couldn't
you
indoctrinate it
don't.
thoroughly.
No, you
Chardsy,
don't.
I
Chardsy,
was
you didn't.
hoping to hear about the flat
Chardsy.
Earth.
So
The
if
ironic part is
you're
we're going in
assuming,
circles.
just hang on one sec.
Right.
If you're assuming that 1 degree per 69 miles was a flat Earth thing,
That's crazy.
Well, I'm asking you how the flat Earth works, man. I thought that's what you guys were telling me.
what do you mean how it works?
How it works. So you're telling me that this observation of Polaris is how it works on a flat Earth. How does it work? Or
No,
sorry, on a round
it
Earth.
is because it's a flat Earth. That's what happens.
Okay, so it's a flat Earth. So you should be able to calculate how high above the Earth Polaris is, right?
No, I just told you, dude. If you want to do that, you have to make the assumption, right? I was talking to you what I was describing a minute ago is if you were to endeavor to determine that, you have to assume that the thing that you're looking at is actually in the your apparent sight, like your line of sight to it actually intersects with the actual object in free space.
Okay,
That's why
so
no one really bothers doing that, and no one's really talking about that. Number one, it's not really relevant. Number two, we don't want to assume shit.
okay, so you can't
So you
determine
can do
where
what
bodies
you can
are
do.
in space.
Chardsy, let's get out of the sky, right? And
Okay.
we can take this. So we can take this radius volume, this radius value that they give you, right?
Uh-huh.
And you can determine where the horizon should be if you live on a ball of 959 miles, right?
Uh-huh.
The horizon distance should be the same if you're over water, should be the same every single time, right? To a physical horizon of a curving ball.
Does that include the refraction of light over distance?
Well, we
At
can add
different
in refraction if you
atmospheric
want, but you're going to have to give me a value of that too.
I
And
don't
you're
know.
going to have to.
I think that's
also you're
dependent
going to have
on
to.
elevation.
What we're trying to prove at the moment is there a physical horizon, right? Because in order for you to give me a refractive index, you need to know where the physical horizon is. Correct?
I guess.
So you would need to show me that the physical horizon is at 1.22 miles times the observer's height in feet.
Uh-huh.
Because that's what it would be based on a ball of the size of radius 3,959 miles. So in order for you to say, oh, it's refracting, so the distance to the horizon looks further, you would have to show me that the horizon is actually in the place where it's supposed to be, the physical horizon.
But we live on a place where we can physically go to those places, right?
Awesome. Cool. So who has done that?
I assume a lot of people.
Awesome. So it should be easy to find then, right?
Yeah.
Yep.
I mean, I assume this whole topic
who
would
has
be
measured the
something that
distance to the horizon?
a lot of people? You want an
No,
individual person?
I want to know. I've been looking for it. Do you know?
Who I don't know anyone personally who has measured
Why
the
do you
distance.
believe it then?
Because I think there's a large body of scientific evidence that supports it.
Like what?
Like what? I don't know, man.
So you believe that there's a large body of scientific information about the globe being this size and the horizon being at the point where it should be for a ball this size, but you
Mm-hmm.
don't know what that is or where it is.
No, that seems like fairly trivial stuff. And
So
at least
trivial. So what's the most important part of a ball?
the
It would be
bounce.
curvature, right?
Yeah, the curvature, definitely.
Yeah, the curvature. So it should be, if we live on a ball of that size, it should be detectable, correct?
Right.
Right.
And I
So
think,
where is all this scientific information that you say is available because you
uh-huh.
believe in it? Where is this information?
Well, I'd say probably the easiest and most definitive stuff would be satellite imagery of the planet that shows the
Nope.
planet
We're
curve.
not going there because we can't
I know you
determine
guys don't
whether
like
this
that.
no because you can't verify it.
Well, I can
Everyone on
verify it.
the earth can verify what they're standing on, right?
Uh-huh.
So without having to rely on anyone else going to a place where physically impossible to go to, because
Right.
we can't determine whether these images are the Earth or not.
Oh, we can
And
determine
if
that,
if
actually.
it is, okay, if it shows, all right. So this is the problem, right? So you have images of the Earth curving. You have images of the Earth being flat. You have images of the Earth with upturned edges, i.e., concave Earth. Now, which one is
Really?
correct, and how do we determine? Yeah, there's heaps of images of that stuff. How do we determine which one is correct, and how do we verify it?
Well, have you ever heard of the concept of validation points?
Go ahead.
So I work in geospatial sciences.
Yep.
We want to make sure that the images coming from the satellites match up with the images on Earth. We take the data from the satellites, we randomly pick a bunch of points, and then we go there physically, and we make sure that what the satellite says is actually what's there.
Okay, so you're telling me you've got a picture of the Earth from space as a
Mm-hmm.
ball,
Uh-huh.
and then you go down to the Earth's surface,
Right.
and you do what from that?
And you validate all of the readings that the satellite sent, and you
Okay,
verify
what readings are you getting from the satellite that's showing you the Earth being a ball?
mostly hyperspectral data, but also, biological data. You can look at different bioindices that exist there, but
So
mostly,
you're looking at plankton, or
no.
what are you looking at?
So you look at what the satellite sent. Most satellites operate on multispectral wavelengths. Some have hyperspectral, right, which is wavelengths of light.
Yeah, so can you show me an image of what you're actually seeing?
Not at the moment, no. I don't have. I
Why
mean,
not?
well, how long do you want to wait?
Well,
I mean,
shouldn't you
I
just
don't.
have it on shouldn't you just have it on your computer?
Oh, because this is my personal computer.
You don't have a screenshot or something like that.
Oh, I
So
mean, if you
you
want me
look,
to,
the satellites that you work with show you a
mm,
full picture of the Earth as a ball.
yeah.
Can I see that?
I mean, if you want to download them, they're big images. I don't
Yeah.
have them stored.
And then how do you determine that the Earth is curving when you get down there?
We use GPS
And how
to,
does that determine that the Earth is curving?
well, if the GPS doesn't line up with the satellite images, then obviously the satellite images aren't accurate.
But what does that even mean?
Oh,
Right, well, you can find the curvature through GPS.
Can you show me how to find the curvature through the GPS?
I mean, if you want to come out, take a flight, but I can't do it.
No, just tell me.
Right.
Can I ask a clarifying question? You're not gonna.
Yeah, man, go ahead.
But Charlie, when
He's
you're
not.
when
He's
you're
not going to tell me anyway. So you might.
I can try and explain, but I don't think any answer I could give you is going to satisfy you.
well, let's
because it
determine
doesn't
that
sound
after
like
you
you know
tell us
how.
then. Yeah.
You guys talked over each other.
No, that's right. You go ahead, Mick.
No, I was just gonna say, continue your thought there, and I'll ask after.
Yeah. So, in what way can you show curvature through GPS?
You can't show it because GPS projects a two-dimensional field onto a three-dimensional object, right? You validate it through GPS.
In what way?
Well, so the satellite shows you the picture of the planet. It shows you all the different points. And the GPS allows you
That's
to
still to be
navigate.
determined. But yeah, go ahead.
The GPS allows you to go to those different points. And using the navigation of the GPS, you can validate that there is curvature, that the Earth
Okay, so
wraps
your
around
argument is
on itself.
because GPS, then Earth is a ball.
I think that's a crude oversimplification that's kind of
Okay,
disingenuous
can you
to my
please
point.
explain to me when you get down to the surface how you determine curvature with GPS?
Right, because you can use GPS to follow the Earth in a circle to wrap it around itself. Right, because GPS goes
Sorry?
from like
What?
180 latitude to
So
negative
when have you?
180.
Okay, so
When you
when have?
cross over any of those, it wraps back around itself. And that works. You can validate that. That's why we use
What
GPS
do you
in
mean wraps?
airplanes
What
and
do you mean
cars.
wraps around? What do you mean wraps back around itself?
It wraps back around. So if you go from,
So you mean like on a latitude line?
or longitude, it goes
Yeah, well,
back on itself
you can't. Yeah, but
because
you
it
can't do the
curves back.
longitude. You can't do a longitude line. You can't do
Oh,
that. You can't
sure you
wrap
can.
around a longitude line and come back up the other side.
Sure you can.
When? Who's done that?
I
Who's
assume the
followed a
U.S.
longitude
military.
line and come back around the other side?
I believe the ISS does it.
Oh, well, we're not talking about that. I'm talking about on the ground. You're telling me that
Oh,
GPS tells you that the Earth is curving on the ground. I'm asking you how, and you're talking about latitude and longitude lines. Now, we all know latitude lines you can follow around in an easterly or westerly direction, and it has to point to north. So you're going around in a big circle. Now you're telling me longitude lines you can go down south and come back through down south and head back up north. Who's done that? To
I think
determine whether it wraps back around or not.
Magellan, I think, was the
He didn't
first
go
guy who did
south.
it.
He went
He did.
east-west, and he went in some weird
He went around
directions too.
the Horn of
Okay,
South
show me.
Africa.
Okay. Yeah. And then where did he go? Up. He went north again.
Yeah, he did.
Yeah. Yeah, back up to the US. Yep.
I don't think he ever even went to the U.S.
Went back up, and then
He
he
did
followed
his
the
journey
coast of the
before the
south.
U.S. was even a
Like, can you
country.
show me? Can you stop
Yes,
talking? Can you
let me
show
post.
me him wrapping around on a longitude line around the bottom and coming back up the top?
Here's this
Longitude.
one. Longitude. Well, there are ice caps. I don't know if anyone's made the polar journey.
So you can't show it then. Can you?
Mike,
I'm still
Mike,
asking you to show me curvature from
Here's
a
one.
GPS. Here's what?
So those 3 maps that you produced,
Uh-huh.
how did you how did they work out the latitude for those maps?
I don't know. I assume this one from the 1980s, they used GPS. I assume the Magellan's voyage, they used some sort of astrolabe. This last
And what
one,
would they have needed? What would they have needed to do in Magellan's times to get their latitude?
they probably would have used stellar references. So
Nice.
probably Polaris in the
Yep.
northern hemisphere and the Pleiades in the southern hemisphere.
When they in that day and age, when they travelled to the southern hemisphere,
Uh-huh.
they used reference. There's a certain amount of reference stars in the southern hemisphere,
Sure.
so they would have needed to have known their longitude. So they would have needed to have known where they were at solar noon, and they then made reference later on at night to certain stars. They never ever used a southern star to work out their southern latitude.
Yeah, I don't believe you.
Okay, this is why, like, when you guys come on here,
Wait, who
there's
is
a lot of
you
the time,
guys?
you guys, like people that
Who
make an argument against the fact.
hold on. I didn't make any argument. You guys dragged me into an argument. When I came in here, I specifically said I didn't want to argue about this. You guys kept saying you wanted to argue about this. You muted me until I started arguing about this. This is not my argument. You dragged me into this, okay? Don't make this
Okay,
don't put me into this group where you're trying to drag me into this. Okay?
all right, I didn't. I don't mute anyone. I'm not a mod, so I didn't know that you were muted. So I'm sorry about that. But
So who is these guys? What have they done to you?
they've hurt us bad.
Well, that's unfortunate. I'm sorry about that.
Yeah.
I came in here to learn about what you guys believe. I didn't come in here to defend somebody else's arguments.
Yeah. Have you learnt anything yet?
No, I haven't, because nobody wants to learn. You guys want to argue about this fucking globe bullshit. I'm not
No. What we're
particularly
trying to
interested
point
in
out.
defending it.
What we're trying to point out is how the Earth is measured. That's all we're trying to point out to you, and it's measured flat. That's the whole point of me just jumping on. I mean, all the other guys had it, no problems. But I thought I'd just jump in and try and make it easy for you. Starting off with the
Okay.
first point of reference, which is an angle measurement to Polaris. That's where all this stems from.
Here's my big hang up, man. Here's the thing that I have never gotten a straight answer to. If the Earth is measured flat, how do we go around it? You know, have you ever been on an airplane before where you go to different continents and it shows you the flight of the airplane, like the path that the airplane is taking, and it's never a straight line. It's always like this weird ass curved line. Like, why is that?
What they're
'Cause
showing
I've
you on the plane. So
Right. So are they
when,
lying? Are
so
they
when a
just
bird,
like fabricating it? Like, what's going on with that?
no, it's just in their geographics. I think it's a GS84. It's just in their graphics. I mean, if a bird, let's say for example, I don't know if you're a big fan of nature. If you follow migration patterns of birds, when they set off, there's a reason why we use the term as the bird flies or as the crow flies.
Mm-hmm.
It takes off and it flies from point A to B, the quickest possible route.
Right. And
It
if
doesn't
that's
follow. It doesn't follow some curved path.
right.
So when a
And
plane takes,
if you project that straight line from point A to point B as the crow flies, right, it's going to be like an arc, right? But if you take a transcontinental flight from the northern hemisphere to the southern hemisphere, I've flown from Los Angeles to Sydney before. Okay, it's not an arc; it's like an S shape. It's a curved, and that doesn't make any sense if it's as the crow flies. So that's what I'm asking about.
so that's how they project the flight path to you.
It's a straight line; it shouldn't be projected that way.
If it's a straight line, why don't they just show the straight line?
Right, because they're using a projection. But what I'm saying is, if it's a straight line, then that straight line on the projection should not show up the way that it shows up on the aircraft.
Have you ever used software or an app like called Flight Radar or any other app to look at plane movements?
Yeah.
Yeah. When you click on a plane, right? Let's say there's a plane taking off from LA and going to, let's say Australia. When you click on it, what do you notice about the flight route? So let's say it takes off and we watch it for a couple of hours. What do you realize about the flight route?
I'm looking for one right now from LA.
Well, LA is probably not. LA is like near the coast. Maybe something a little bit more inland. So
All right.
what I want you to do is look at the flight path, right, across land, and then when it gets out of radar, it becomes projected. So the flight path is straight, perfectly straight, heading from point A to point B. As soon as it goes around about 8 nautical miles off land and it loses radar, then it shows a projected route. And it'll change colour from purple to a yellow or a blue. And then all of a sudden it shows the arc. But when it lands on the other side, you follow the blue or yellow arc. But when it hits land or 8 nautical miles out of land, it's straight.
See, I'm looking at a flight right now from Des Moines, Iowa to Los Angeles, California, and there's an arc on it. It's not straight.
So from where to where?
From Iowa to California, all over land.
And what app are you using?
Let me see. It's called flightconnections.com. I posted what I'm seeing in the chat.
Yep, that's cool. Yeah, I love it. So when you hold a compass, and the compass obviously points north because that's the primary cardinal direction. If you were to move west or east, for any long period of time, would you be moving in a straight line or would you be moving in an arc?
If you're moving directly relative to the compass, probably move in a straight line. I mean, that's an interesting question. It depends on how you're framing it, right? Like, are you holding the compass north the whole time, or are you moving off the initial reference point?
We want to keep our north reference.
Okay.
With our north point on the compass, and we want to move either east or west.
Yeah, so if you maintain the compass bearing, you're going to move in an arc.
Okay. And is that necessarily a globe proof or a flat earth proof?
Well, see, that's a good question, right? Because I've asked about what is the shape of the flat earth? What is the nature of the flat earth?
Well, flat is an aspect. It's not a shape.
Okay. Right, but
topographically flat.
Is the flat earth one such that the North Pole is like the center, or is do you know what I'm saying?
You can make an azimuth from any point on the Earth, right? And there's many maps that show that. Obviously, one of the ones that people show is the one on Air Force One, where Washington is the azimuth. You can make an azimuth equidistant map from any point. It just so happens that we have a magnetic North Pole. So that is where the ancient people, up until now, had developed their maps from. And that's where they've used their cardinal directions to travel. That's
right, but
just
it's
just how it's developed.
Magnetic north changes, though. It's not always the same place. It's shifted.
Do you know that for sure?
Yeah, it's been mapped. I mean, and they have to constantly update because aircraft, especially old aircraft, still use magnetic north in their compasses, and it shifts over time. It's in the middle of Canada now for some reason. Like it moves. It's not a fixed point.
So what you're saying is that last year my compass was pointing towards the North Pole, but this year it's pointing towards Canada.
No, if you have a magnetic compass, it's never pointed towards the North Pole. It's pointed towards magnetic north. Which, if you've
Right.
done, I assume you've done like orienteering or something like that. There is a degree shift, right, between magnetic north and true north, and that's been shifting. It's been increasing.
Well, that's an assumption of. I'm not going to say yes or no to that.
It's
But
not an
what I know
assumption. It's been
what I
observed.
know is that when compasses were first developed so many hundreds of years ago, they're still pointing in the same direction north today
Relatively.
than they were 100 years ago.
No, that is absolutely not true. Magnetic north has shifted, and it's continuing to shift.
Okay, well,
It's
I
not
don't
the
know
same.
that for a fact.
Look, I'll
If you
post
can,
a map here.
well, that'll be a story which none of us could prove.
You could prove it
What we
right
do,
now. Go outside,
well,
measure magnetic north, and then 5 years from
yeah,
now, go out, measure magnetic north, and see if it's pointing in the same direction. It's
all right.
shifting.
I'll tell you this. I've been around this subject for nearly 13 years,
Oh,
and I've been using compasses for way longer than that.
okay.
And where I live, magnetic north has stayed the same the whole time. So the first time I used a compass, when I did my first orienteering course when I was 11 years old, right? So we're talking about, you know, the 37th south parallel, roughly where I live, where I reside,
Right.
never changed.
It has changed. You might not have been able to perceive it, but it has changed.
Okay.
And especially up in Canada. So I don't know if you know how airport runways work in North America, but basically the way they number the runways is the declination from magnetic north, not geographic north, but the way they number the runways is the number of degrees off from magnetic north. And they've been having to
Okay. So they have
repaint the
north, south.
runways on the runways. They've been repainting the numbers because magnetic north has been shifting. So all the instruments in the aircraft, you know, have been changing their readings. So they keep repainting it
All right. So
because it's changing.
one of my customers for 11 years has been the Melbourne International Airport, Tullamarine.
Mhm.
We have upgraded all the runway lighting there. We do a lot of work there,
Sure.
convey systems. So what we have in Australia, and I'm pretty sure all around the world, we have east-west and north-south runways. Now, they never re-tarmac the runway to align with the shifting north-south, east-west.
No.
They have stayed the same.
I wouldn't
So,
expect them to because it's done
right.
based off of the winds, right? It's not done with the
Okay.
numbering. And I'm not talking about like, you know, I'm talking about in North America, the numbering is based off of the the degrees from magnetic north.
Okay,
Not
I'll take
not
your
the
word for it. I
not the
don't know.
physical.
All I know is the compass points north and always has. It doesn't point towards Canada one year and then North Pole the next. You have
Range.
you have declinations, right, at certain degrees, right, which is very weird because in the south where there's a massive shift of declination, it makes up for the supposed issue with longitude and latitude lines. I can't prove that, but that's my opinion.
All right.
But you know, we've given you a lot of reasons why the Earth is measured flat.
Oh,
Could you give any reasons why it's not measured flat?
yeah. I don't
I'm
think
happy to hear
any.
them. Like we're all happy to hear them. You know, we're not flat Earth evangelists. We're just here to discuss with people about the fact that the Earth, as we see it, is built on, navigated, flown above, sailed on, mapped, flat.
Yeah. I'll say just from my personal experience, I work with satellite imagery quite a lot. And if you work with those images under the assumption that the Earth is flat, then it's very difficult to get anything accomplished because things don't line up, things don't make sense.
It
You
is
have to
Photoshop, but it has to be.
see, so at least there's an answer, right? It's
you've said that.
photoshopped.
Well, you've said that to us before, right? But you haven't shown that that's the case.
You want me to show you what I do for a living? Why don't you
Yep.
show me a picture of your job, man? I don't want to do that.
Okay.
I don't know you
I'll
people.
show you.
You just hit Command Z a lot. You just hit Command Z,
What is
right?
Command?
To add the cloud.
Is that undo?
Who was that guy? Peter Simmons? Was that guy?
Yeah. Just to add in a few clouds here and there.
Yeah, because
No,
you said
This-
you said you go off satellite images, but
Yeah.
you said in those satellite images you see Earth as a ball, so you see the whole ball, right?
I mean, yeah.
Yeah, the one side of it. Yeah, I'm not stupid. Yeah.
The ones. Yeah, they don't let us see the other side that's classified.
Hey, what format do the satellites send these images to you in?
Depends on the satellite. Usually, cloud optimized GeoTIFFs, net CDFs are good too. Some of the older ones have weird formats; you have to convert them. But GeoTIFFs.
Is it all just AI?
Oh yeah, it's just Chat GPT, just generating everything.
That's cool.
Yeah, it's pretty cool.
Cool story, bro.
Yeah. But I mean, you have to wrap it, because if you don't wrap it, if you don't, assume that it's in a curve, if you try
Did you
and
hear that
project it
flat
flat,
today? He wants a rap, dude.
yeah.
Oh yeah.
Can we do
You
a
just
wrap?
gotta wrap it, huh?
Can we get a wrap? You a rapper?
Saran wrap.
Uh, but that's my perspective. That's where I'm, coming in from it. I appreciate you talking to me, just because a lot of people in here tend to be pretty hostile.
Yeah.
So I do
That's all right,
appreciate
man.
it.
See, we can have a conversation. Next
We
time I
can.
ask you, let's have a conversation. We can. You know that we can have a conversation, right?
I'm down, man. But see, here's my thing. It's like the last guy who I had a good conversation in here, he got banned. And like every time I come in here, it's always hostility. It's always people wanting to like argue about shit.
Not
I'm much more
always.
interested. It's pretty close, man.
Hey, bro,
I mean,
can you imagine if all your friends and your family and your loved ones and people you go to the store and buy stuff from at the store all believed in Santa Claus, and around Christmas time, all of them dressed up as Santa Claus and thought it was crazy if you didn't put cookies out underneath the chimney. They thought you were crazy. You're not putting cookies out. You're crazy, and you got shunned by your family because you didn't put
that would
cookies out.
actually be
That's
pretty
what
cool.
we go through every day, bro. Something similar. You know what I mean?
Well, I'm not here to persecute you, man. I'm not here to
I
like
didn't say you
attack your
were.
beliefs. I'm here to learn. I'm here to understand what you believe. That's really all I'm here for.
So can we cap it off? And one of the original questions was, do you know why we say the Earth is flat?
I have some preconceptions. I'm sure some of them aren't correct. I know that a lot of people have done their own experiments that claim to prove that the Earth is flat. The fucking bathtub argument. I've seen the black swan picture.
Bathtub. What's
Yeah,
a bathtub?
so like right, like you fill up your bathtub and the water's flat. So
Yeah, but
the
you can't.
rest.
Is this when
What?
the white rabbit jumps in?
No, I mean I'm not trying to insult you. This is just the
I
arguments
don't
that
think
I've
you've
heard
heard that in here. Maybe you would have heard it from someone saying, okay, if you fill up a bathtub, is that flat? And then they move on to a swimming pool, and then they move on to a lake, and then they move
Right,
on to the ocean.
something
That's
like
when you
that.
would have heard it. Wouldn't be a bathtub argument. It's just demonstrating at what point does the water start curving. Right?
Right.
That's
And I'm not
kind of
trying
an
to
analogy for that.
to insult anyone. That's just me summarizing. I personally think, the bathtub, if you had sufficient equipment, you could measure curvature. I mean, even
Okay. So has anyone measured a lake curving?
yes.
Who?
Oh gosh, I forget the name of the lake, but it's essentially long enough that you can measure the curvature.
Like Pontchartrain, yeah? Is that what you're talking
Is
about?
that what they call a lake curve?
No. Oh gosh, what was the lake called?
Pontchartrain, yeah? With the powered cables and transmission lines? Is that what you're talking about?
Pontchartrain, Minnewaca, Mirror Lake, I think is another one.
What did they measure?
They set up an observation post on one side of the lake, and they set up a beacon on the other side.
That was on Netflix.
I think it was there was one on Netflix. I think there was another one. There was a guy did on YouTube that was pretty good.
How much curvature did they measure?
Oh, I couldn't tell you. I don't remember.
But when you're saying that you can't measure it because of refraction?
With the naked eye. I mean, they had optics. I don't think you can measure anything really.
Okay, so if we showed you optics of the Earth's radius being larger than 250,000 miles, would you believe that? I mean, it's taken with optics, right?
250,000 miles is pretty far.
Yeah, it's like from here to the moon. That's the radius, the supposed moon. So that would just be the radius.
Right. So I think at that point, my question is, like, why can't you just go up on a really high hill and just see anywhere on Earth?
Well, we can't. We can see what you guys call the horizon, right? Taken from 1 foot above the observer height, and we can see the horizon past 10 miles.
Right. But shouldn't that be scalable? Like, the further up you go, the further beyond the horizon you can see.
Horizon.
So you can essentially just see anywhere.
Physical horizon is supposed to be at 1.22 miles.
Okay.
So with optics, like you said, they've used optics. We've used optics and shown it to be not the case that it's a ball of 3,959 miles.
Okay. Is that like a hard rule
much-
that's been established, or is that just like
That's
hard
their
rule.
math.
So I'm happy to run through the modus tollens with him if you like.
Yeah, go for it, man. I'm cooking anyway.
If the Earth
Yeah,
was
you
a
are.
sphere, if the Earth was a sphere with a radius of 3959 miles, then all distances to the horizon from a 1 foot observer height would be no more than 1.225 times the square root of the observer's height. That is the globe Earth mathematics. When we look at that picture that you referenced before with the oil rigs, the horizon is well beyond the second oil rig, which was 9.2 miles.
right?
So therefore, the Earth is not a sphere with a radius of 3959 miles.
Does that equation factor in atmospheric conditions and refraction over water?
There is no refraction over water. Refraction only happens between two mediums, different mediums.
Right. So like
So
aerosolized water and air.
No, not in air. You're talking about diffusion. There's a whole lot of other atmospheric conditions that happen, but what they
Like
don't do,
different
what they don't
gradients
do,
of aerosolized water.
what they don't do is bring the horizon up behind two different visible objects at two different measurements. That's what no atmospheric condition can do.
Okay.
So what they do say is terrestrial refraction, which is nothing to do with any optics. It's just 7/6R, which is makes the Earth bigger and makes an excuse for the reason why, when we developed really good photography, the reason why we see too far. But that simple modus tollens just destroys the Earth with a radius of 3959. You can't get around it.
Okay. So would it be possible to discuss what the nature of the actual Earth is then, aside from what has been purported? Because that's what I'm really interested in, right? If I'm someone who believes that the Earth is round, it's a sphere, and I look at all these maps that, sort of substantiate that opinion, but now I'm finding out the Earth
So
is flat.
you're gonna throw out all the information because you don't know where the edge is, right?
No, I'm not throwing out any information. I'm
So
asking for more information.
if you measure and observe a surface to be flat and you don't know where the edges are, does that mean that that surface that you're measuring flat is curved?
No, dude. I'm not trying to
Okay, so
disprove
what does it matter? Why does it matter?
because I
You,
want to
you
know. Yeah, I mean,
Gato
you
just
guys
give,
seem
Gato
like
just
you.
gave you some information. You don't want to talk about that information. You want to talk about something that no
No,
one can confirm, right?
I'm
So you want to
accepting.
get into an argument or a discussion about something with no conclusion instead of looking at the
See,
facts.
it's very difficult for me. So, say I accept this, right? For the sake of argument, for the sake of discussion, I'm accepting what he's telling me, right? I'm not arguing with it. I'm not trying to disprove it. I'm accepting it. But now I have other questions. And it seems to me like these other questions you guys don't have answers to. And that's just what that's where I'm struggling. Is I want answers. And maybe the globe Earth thing is wrong, right? But those guys at least have answers, even if they're wrong answers. I'm asking you guys, I need some answers here. What does it look like? What are we dealing with here? I'm not trying to like
It
argue.
looks
I'm not
like a flat surface.
right,
What do you
but
mean?
so is there an edge to it? Does it go on forever? Is there a
Well,
center to it?
if there is a vacuum of space, then there must be an edge with a container. Otherwise, you can't have gas pressure.
Okay.
If there is no vacuum of space, then who knows?
And is there a vacuum or is there not?
I don't know. No one's ever shown me a reading of 10 to the negative 17 torr.
That's unfortunate. Because
Yeah.
that's really where I think the most interesting part of this discussion lies. Is like,
Okay. Do you know the lowest recorded pressure?
I don't, and I'm not trying to argue with you.
No, I'm not. I'm just wondering, do
I
you
don't.
think there's a vacuum of space?
I do personally.
How would you confirm that to yourself?
I think if someone sent something up really, really high outside of the atmosphere, and then had it dropped back down, you could probably see the effects and determine whether or not maybe there's not a complete vacuum, but maybe there's something pretty close to it.
Hey, you know what's weird, bro? Is certain parts of the hour, you continually say the same thing. You say, "I'm here to learn something. I just want to learn something," and then you switch it back to the continued thing of, "I'm not here to argue with you. I'm not here to argue with you." I'm just pointing that out.
Okay. You're welcome to contribute to the discussion, man.
Hey, Chardy, can you have gas pressure without a container?
Yes. I mean, if you believe in certain things like gravity, yes.
Which gravity would that be?
Well, like if you believe that all objects attract other objects, and you put quite a lot of gas together in one place, then the mass of all the gas is going to compress it down to the center, and you have pressure, even though there's no container there.
Is that why
Okay,
gas stations have a quick drive through to wash your car?
What?
You said they all attract together.
Yeah, over very vast
So,
scales.
where there's large amounts of gas condensed into one specific place, everything's going to be attracted to that.
Very large amounts.
Like larger than a gas station holds?
Oh yeah.
How much larger?
I mean, bigger than the size of our planet. Bigger than the
Which
size of
planet?
our. Oh gosh, what planet do we live on again?
A good one.
Gosh.
Hey, so this gravity that you're talking about, that holds all the air inside as our container. Let's say I had a vacuum chamber here at sea level,
Right.
and I evacuated that gas chamber, like I do when I do my testing on gas chambers in universities. Let's say I evacuated that gas chamber, but inside that gas chamber, I had another container that was air at the pressure outside. If I took the lid off that container inside the vacuum chamber, what would happen to the gas?
Sorry, I'm struggling to think this through. So you have an
Let's say I
empty.
have a shoebox. I've got a shoebox full of air at atmospheric pressure, 14.7 psi, and I put it inside my vacuum chamber. I
Okay.
evacuate the vacuum chamber, and then I take the lid off my shoebox. What's going to happen to the air inside the shoebox?
The air goes out into the vacuum chamber.
In all directions?
Yeah. I mean,
Okay, so where was gravity holding the gas down there?
well, there's not sufficient gas in your shoebox to generate the gravity to hold it in place because it's a
You know,
shoebox.
gas is unbonded, yeah? So you can't talk about quantities of gas. They're unbonded. They're all individual particles floating around, doing their own thing, bumping into each other, bumping off the wall. PV equals nRT. Do you know what the V is in PV?
Volume. No? Not
Okay, so
volume?
it's volume.
Oh,
Yeah.
it is volume. Okay.
Yeah, that's volume. So gases bouncing off their container is what gives you pressure,
Mm-hmm.
right? Gases, which I just proved right then, are not succumbed to your Newtonian gravity. They
They
will
are.
defeat gravity with that. Well, they'll defeat gravity with that simple experiment. Where are all the gases? All the gas cycles. Where are they generated? Here on Earth.
All of them?
All the gas cycles. Where are they generated?
I mean, on Earth?
Yeah, at or around about sea level.
No, some
That's
of them.
That's where all the organic material. That's where all
there's
the organic material is.
gas cycles that go on in the upper atmosphere. It's what clouds are, rain is.
We're talking about this cycle. Where is it generated?
Sublimation, hail. You guys get hail down there?
So
That's
it's
not at sea
all
level.
generated. The cycles are all generated at or around about sea level, and then they travel in all directions, including up, sideways. So gas particles do what they want. They're not pushed down by gravity. So
they are.
So with a delta P, so with your delta, such as if you've got a container of anything, such as a hydraulic fluid, oil, water, anything, including air, your delta first, right? The change in different kinds of pressure comes after you have pressure. So you must have pressure first.
I guess. If you're
But
doing
it's not arguing with you. I'm just telling you.
No. If you're doing it at sea level.
Do you understand the second law of thermodynamics?
Oh gosh, which one is that? Energy cannot be created or destroyed. It can only
energy
be
systems
transformed.
decrease over time.
Oh, entropy.
Yes.
I might have been thinking of the third one.
So when you have a cup of tea, you sit it in the room, it's going to eventually work its way down via entropy to room temperature.
Mm-hmm.
If you have a Pepsi can and you open it up, it'll equalize with the outside pressure.
Right.
Right. Well, if you have water molecules that are evaporated, eventually they'll condense and fall. Entropy in the hydraulical cycle. So what gravity can't do is it can't defeat entropy.
That's
Anyway,
a good
I've got to
point.
go.
Yeah, that's
Happy
interesting.
talking to you.
Yeah, thank you. I appreciate the conversation. I don't think entropy is gravity isn't energy though. I mean, gravity is a fluctuation. It's a ripple in space-time. It's not an expression of energy.
Is gravity a stitch in time saves 9?
I don't know what that's referring to. Is that a meme? I mean, even gases have mass. Mass influences the fabric.
You think gases go to church every Sunday, to Catholic church?
No, I think gases are Protestant.
You said they have mass.
Yeah, Protestants have mass. I don't think they're Catholic. Definitely Protestant.
So the gravity you're talking about is a religion?
Yeah, definitely. I think NASA created it, obviously. They indoctrinated the entire planet. And obviously, we all worship gases now. And that's why we go to Mass on Sunday.
When you say we all, you don't mean me, right?
You don't go to Mass?
Did you win the Super Bowl? Or go to the moon?
I did both of those things, actually. But they were separate years.
So I didn't, though. So don't say we when you're including me and things like that.
I'm sorry. You'll get there someday. Okay, well, I'm gonna head out. It was good talking to you guys. Timbo, I hope to see you again, man. And Jado, and Jado, Jado. I appreciate you guys. I'll see you later.